my project is attention-based neural machine translation, and I come from Hebei University of Science and Technology, the city of Shijiazhuang, Hebei Province, China, and my mentor is Ryan. Firstly, why I choose this topic. As we know, the attention mechanism is used to improve the neural machine translation by selectively focus on just the parts of the source sentence, not the whole source sentence. The blue scores is improved by using the attention mechanism. And recently, there's another paper named "Attention is All You Need," and it proposed a new simple network architecture, which solely depends on the attention mechanism and dispensing with the convolutions and the recurrence entirely. So, and the performance is also improved. So the attention mechanism is very useful. I think I want to take this opportunity in this camp to make a full understand with the attention mechanism and try to implement the local attention model, which is proposed in this paper and implemented it by using the TensorFlow. So that's my goals. Firstly, I'll generally introduce the neural machine translation. The task of machine translation is when you get a source sentence X, you need to find the target sentence Y to maximize that conditional probability. And for the neural machine translation is to use a neural network to maximize the translation performance. And the most proposed models belong to the encoder-decoder family. As this picture shows, this side is the encoder. It encodes the whole source sentence into a fixed length vector, and then decoder use this vector to output the translation. But there is a problem for this approach. That is, it's difficult to cope with the long sentences because it's difficult. The information at the quite beginning will be lost at the final vectors, and especially when the sentence is longer than the training set sentence. So some researchers propose to encode the source sentence into a sequence of the vectors, not a fixed length vector, and selective parts of the vectors while doing the translate. So this is called the attention mechanism. And so the main idea of the attention is to align the words. So the alignment function is very important for the attention mechanism. And next, I'll introduce how the attention-based model works. In this picture, the blue side is the source side, and the red side is the target side. City is called context vector of the source sentence. So city is trying to capture the relative information of the source side to help to predict the target word YT. So each time when we want to predict the target word YT, firstly we need to use the target hidden state HT and combine with the source sentence context vector CT to calculate a new HT, and then use this new HT to predict the word. So the key issue is how to calculate this CT depends on all the source hidden states, HS. So this, how to calculate CT is the most important thing. There are two different types of attention models. One is global and another one is local. Actually, this picture shows the global attention mechanism model. So this is the same picture. These functions, I think most of you are familiar with these functions. This is how to calculate the CT in the global attention. Depends on the target hidden state HT, we use the first function to set scores for all the source hidden states. And then we use the softmax function to get the probability for each source hidden state. So that probability acts as the weight. And finally, the CT is calculated just by the weighted sum. So this is global attention. But there is a drawback for this global attention. That is, each time you want to predict a target word YT, you need to attend all the words in the south side. So it will be expensive when the sentence is long. So in the local attention, just try to consider a small parts of the source hidden states, not the whole source sentence states. So the most important thing for the local attention is how you to find which part you are focused on. So there are two steps works for their local attention. First is you need to use the target hidden state HT to predict a position PT, and it's called aligned position. And depends on this PT, you can find a window, and the window size is set empirically. So after you get this window, you use this function to get the aligned weights for the source hidden states within this window. And then CT is calculated just by the weighted sum, just consider the source sentences within this window. So this is the local attention. So for my job in this camp, I just implemented this model and implemented the local attention model and uploaded my project to the GitHub. And this is the file list. If you are familiar with the TensorFlow sequence-to-sequence model tutorial, you will be familiar with this file list. So the last one, the translate Python file is at the main file, and the data utilized Python file is to do the data preparation. And the sequence-to-sequence model is just to build the model graph, and the sequence-to-sequence local, it contains the different functions which is called in sequence-to-sequence model Python file. And this file includes the attention-based function, which is called in the sequence-to-sequence model. So my main of my contributions are included in that file. I implemented the local attention model in the first function named the local attention decoder. And in this function, you can see, firstly, I depends on the target hidden states HT, I get the position PT, and use that PT to set a window and calculate the new align weights by consider the Gaussian distribution. Consider the Gaussian distribution. Oh, I think I missed this part. This Gaussian distribution here. This Gaussian distribution is to ensure when the words is close to the position PT, it will receive a higher weight. So this is the first function. But when I implemented this function, I found it's not convenient to implement the window mechanism by using TensorFlow, because the input is the batch of sentence, not one sentence. So for the sentences in this batch, the predict position is different. So it's not easily to get a batch of windows for this sentence by using the normal tensor operation. So I implement another function named local attention decoder no window. In this function, I just predict the position PT and calculate the new align weights by using the by consider the Gaussian distribution, but no set the window. And the last one, the attention decoder is just the global attention which is provided by the TensorFlow. So this is this file. And this is the training process. And this is the training curve. I just trained the model on a smaller set, the data set, because the NMT data set is a little bit large, so it's difficult to train it and to get some blue scores for me. It's difficult for me to do that. So I just use 20 doublins to do the training and get this curve. And I'm so sorry I didn't do many comparisons. Firstly, the first reason is the data set is a little bit large, so it's difficult for me to get some blue scores. And the second one is because of this model is already proposed by the paper, so for me, I just want to implement it by using TensorFlow and make me a better understand of this attention mechanism. And what I really want to do is I really want to add some semantic informations into the attention in neural machine translation. People always want to add some semantic information into the neural machine translation, but the results are not good. And some researchers proposed a model as named tree LSTM several years ago, but the performance is not good. I think it's maybe the semantic information or the syntactic information is difficult. It's not easy to control in the deep neural machine network, because you don't know how many useful information will be left after so many layers. But I think in the attention layer, semantic information will be much easier to use, because the main idea of the attention is to choose a subset of the vectors adaptively. So it means when you want to predict this target word, you need to find which parts of the source sentence is useful. So I think for this layer, the semantic information or the syntactic information will help you to decide which part is you can focus on. So I really want to do this part of work. And that's all for my project. And I lost 1 month. 1 month, how time flies. So I just feel like I just arrived here. And it's very good to focus on one thing every day. And every morning we have a WhatsApp meeting, and that's really good for me. You need to think about your project, and you need to make a plan. And we also have wonderful weekends. Each weekend is so wonderful. We went to a different place and tried different delicious food, and we lived together for almost 1 month, and I won't forget you all. And that's all. Thank you. No questions?
No, yeah. So, any questions? Thanks for the closing comments. Yeah. Any comments?
So the computation in the neural translation, the computation, I guess, is going to have to do. So at every forward pass, it has to do backwards pass, then step back, and go back again. Is that how attention works?
So you mean the attention? How the attention work?
Like in the implementation-wise, does it create, because you're reducing time step given by the, I might have just completely misunderstood how attention works.
So you just want to know how the attention works in the neural machine translation?
Yeah, or like what's going to be the computation cost? Like how many times do you have to visit a time step
Oh, the time. So you want to know the cost of when we use the attention?
Yeah. So if it's 100 time steps, and if we get another time step, do we have to do like a complete backward pass to gather all the information from the whole sequence again? Is that?
I'm not quite understand your question, but I can explain the process.
Yeah.
So the input. So firstly, the input is into the network, and then the encoder layer will be an output. So this output will be the input of the attention. Then the attention actually work with the decoder together. Okay, so just the attention is just in the middle of the encoder and decoder, and much close with the decoder.
Yeah.
Have you compared the amount of time, relative time that is taken by maybe a local attention, how much time factor is there? As you mentioned that global attention maybe takes a large amount of data, right? Large amount of time.
Global attention will need more time. Yeah.
So what's the time scale factor for that?
You mean the competition with the compare with local? So you can see the paper. Yeah, I think I didn't do the comparison in my project because in that paper is that the local attention will use less cost, especially on the long sentence. So I didn't do that comparison, but you can read that paper. That paper show the results. Yeah.
So do you have any plan to compare all this complexity, time spent, and everything on your implementations? That would be very awesome.
Yes. There is another one because the other authors of this paper, they implement the local attention by using MATLAB. Yes. So. And I implemented in TensorFlow, but I don't know, depends on my course, the time because there's so many. Yeah.
Okay, so one more.
Speaking of the pre-LSTM, which implemented the architecture using the parser. So this is not directly related to your work, but more general LSTM attention translation. Do you think that whole attention-based mechanism like attention is all you need, or convolutional sequence to sequence, or argument can replace fully replace the RNN-based machine translation algorithm?
I just asked this question when this camp beginning. I remember, and I think I asked this question to that professor. I remember, and his answer is it depends on the application and depends on the language. And some languages, or because of the features of it, so sometimes you cannot dispensing with the RN or CN entirely. So sometimes maybe you need them. But in that paper, the attention is all you need. It shows the attention is very useful. So I think maybe it's enough. I want to do more works, just focus on it. Okay, thank you.
Okay, so then let's thank our speaker one more time.